Ohio State University is a fairly large campus. We have a lot of students traveling for classes, coming to school, leaving school at the end of the day. The university provides a service called CABS, stands for Campus Area Bus Service, and it's a fairly large system. We've taken the CABS service and turned it into a lab, so in addition to providing a transit service, we're actually using it for research and educational purposes.
The OSU Campus Transit Lab is sort of a collaboration between researchers, academics, instructors, operators of the lab, technology providers. We like to think of our lab as being a living lab where the actual operation is outside in the field rather than in a controlled environment.
A lot of campuses don't have the mass that we have, and actually a lot of them either run a small in-house service or they contract with the local transit authority.
The bus service serves 4 million passengers per year because we're such a large campus.
More than 50,000 students, you add the faculty and the staff, and we're talking about a large town.
So OSU is unique both in its scale, in sort of the complexity of the transit route. It's also unique in terms of the types of places it serves. We have bus routes that serve off-campus residential areas. We serve the core of campus. We serve a large park and ride facility on West Campus. We serve the large hospital area. So there are lots of different land uses and types of traveling passengers that are served by this system.
We're a small city at Ohio State University. We transport a lot of people on our bus, and we are actually pretty comparable to many cities across the United States. So they can kind of test out some principles and ideas on the bus, and then hopefully that would then make public transit opportunities available for others using some of the techniques that they've done.
The advantage of having a lab like the Campus Transit Lab is that it allows us to, in fact, very easily collect such observations in the field.
We're conducting several areas of research. Probably the one that we're sort of pushing the most right now is trying to infer what we call origin destination flow patterns.
We're interested in knowing where people start their trips and end their trips. One of the things that emerged is that there are certain origin-destination pairs that could be better served if certain routes are redesigned or if a new route is actually introduced as part of the network.
Urban areas are always interested in where the congestion is, what times of day the congestion is, where traffic is slower or faster.
Where are the congestion areas and at what time of day do they occur? For transit operators, it's actually very meaningful because if we can actually detect changes in those long-term traffic patterns, they can more quickly respond by revising the service so that the buses are not delayed as a result of these congestion points.
One of the things we do is our students get on the buses and collect information from the passengers, and anonymous information, and the major idea is where the passengers who got on at one stop, where they're getting off. This is easy, relatively easy. It's still time consuming and difficult. We have to send students out there for long hours to collect the data, but one of the difficult parts is the institutional arrangements that allow researchers to get on and sort of do this in the regular operations of a transit service.
You'd want to collect data on a much larger system that's serving the wider population. That tends to be much more costly, but also involves a lot of red tape. Our relationship with the providers makes this a very easy thing to do.
The Campus Transit Lab offers the opportunity for graduate students in statistics to work closely with graduate students in transportation and to learn to develop meaningful statistical methodology in transit-related problems.
We're not just moving people around campus, it's a learning institution, and we like being a part of it as well. And it's been a wonderful partnership.
The lab's just outside the door for the students.
So it's not this abstract thing somewhere else. They're actually engaging in something that they are in themselves customers of, and that brings a certain element of excitement that I think is quite valuable.
So the methods we talk about in the abstract in the classroom, we can sort of enhance with real data, and also the students understand the situation, the environment that they're dealing with. Well, there's lots of technologies on the bus. The main ones that we're using are the automatic vehicle location system and the automatic passenger counting system.
Here at the Service Annex on Kennedy Road is something that most people don't get to see. This is where we store all 33 buses. What we have here is a smart bus system that we purchased jointly with Transportation and Parking Services and the College of Engineering in 2007. With this system, we were able to see exactly where people are getting on and getting off.
In the past, if people wanted to know how many people got on and off at stops, they had to put people on the bus or people at the stops, and it was very labor intensive, and you could only get one bus or only one stop with a person.
We also provide this data to the College of Engineering, who've done really fantastic things with the data, and really it's been a great collaboration.
We get a lot of information that we couldn't get before. The other type of technology is the automatic vehicle location.
So AVL, or automatic vehicle technologies, allow us to determine where the bus is, or all buses are, at each instant in time. And as a result, we know how fast or slow they travel, how long it takes a particular bus to go from one stop to the next stop, but we also know how long typically the bus would spend at a particular stop letting people on and off.
The technology that we've implemented have been really beneficial to the student population and all of our riders.
One of the big benefits of having this technology is if I know where my bus is at any time, I can also predict, I can have a better estimate of when it's going to arrive at the next stop. One
of the most important aspects of public transit service and many travelers actually complain about is the process of waiting when not knowing when the bus is going to show up, or the process of transferring and ending up having to wait again to catch the next bus to the final destination.
And so with this AVL technology telling us where the bus is, we can predict when the bus is going to arrive at the next stop.
One of the features of the Campus Transit Lab, and in fact of the service being provided to our students, is traveler information systems.
We get live data updated every 20 seconds to provide real-time information to our passengers. We have LED signs at 12 of our most popular stops.
The students can access a map where all the buses running on campus are actually shown as icons. Students can access this type of map either on their smartphone or on a computer lab, on their computer or laptop.
I can see on my web-enabled phone, or even I can text now to figure out when the bus is coming.
The texting is utilized over 8,000 times a day, and the website sees about half as much, about 4,000 times a day.
It's exceeded expectations, the number of people that are using the text services, the web services, to actually access the real-time information.
Providing that information just on its own is helpful to ease any anxieties that travelers are having. More proactively, that information may allow them to plan their trips differently. Again, the presence of this lab is a fantastic resource.
It is kind of the first of its kind, I think, internationally.
But we want to take advantage of this setting for research, education, and actually turn our results from the research and the education into outreach to help the operations here on campus, but also to transit in general.
The type of research we're doing will bring attention to the specific benefits that can be derived from these various uses of the data. We're all aware of the global warming problem and the various contribution to that problem that comes from the transportation sector. Public transit by many is viewed as, when utilized effectively, is viewed as an alternative means to the single occupancy automobile traveler. Of course, that only would work if the public transit service is a good alternative. All of the pieces that we're working on, whether you are improving planning or design of service or operations, you are in fact placing transit in a more competitive situation with respect to the alternatives.
We've promoted the idea that this can be done, and then people, the transit agencies are using these origin destination flows to do better planning and operations.
Our partnership between civil engineering and providing the bus has enabled over $3 million worth of research dollars to come to Ohio State.
The Ohio State University is dedicated to education and research, and they think it's great if they can provide sort of an outdoor working laboratory, a test bed for certain methods, certain approaches to come up with better information from the data they collect, that then we can go out and say, not only OSU's transit system can work better, but Pittsburgh's transit system can work better, or Chicago's transit system can work better with the methods that were developed at OSU.